Okay, so we've got some basics of how to play around with references, and we did a little bit on pointers before. Now I'd like to show us. Let's get back to basics with a new program. Let's get rid of everything in here. Let's copy this off my website if you want to see it again. So we don't need any of this anymore. We'll go to a completely new program. Now we're going to have 4 sections in this new program. The first section is going to basically take an integer, and what we'll do with this integer is we'll change it directly in a function, because you might be asking, what's the point of pointers? There's a bad joke in there somewhere, but the main reason we like pointers is because instead of handing around large globs of material, we can just send around keys. So later on, I mean, it's with an int, and you can pass an int to a function and get an int back from a function without much cost. But if you were to send an array, a huge array to a function, copy that huge array into a local functional array, do some processing on that local array, and then send back another huge array back to the main program, which would then have to copy that huge array from the function back into another huge array in the main program. That's a huge amount of work. Much easier just to pass keys around. So I send you some keys to my safety deposit boxes in the function then goes into my safety deposit boxes, messes around inside there, changes things, then sends me the key back again. It's much quicker and simpler to send a pointer than it is to send a whole thing like a huge array. Now we'll get onto arrays in the next lesson, but for now we'll just do a basic thing with an int. So we're going to change an int in one of 4 different ways. So I just need to set up 4 different sections. So we'll set up 4 sections. In the first section, I'm going to change an int the old-fashioned way. So it's just going to be, I'm going to create an int, set it to some number. I'm then going to call a function, and I'm going to set that int to whatever the function returns. So what I'm going to send off to the function, I'm going to directly change the number, and I'm going to double it. So I'm going to call that drNumDoub, which is direct number doubling. I'll put a little f on the front just to let me know it's a function. I'm going to send off the integer I've just created, which is equal to 10. So I'm going to send off that variable. It's going to go up to some function that I'm going to kind of have up here, and then that function is going to return a number and then go through the left hand side to resetting the int. So let's do the function then. It will be returning an int. Let's figure out what it's what did I call it? I called it this, didn't I? There we are. And obviously we'll have to set up a local variable in there. It's going to receive an int, and then it's going to just double that int and then return its own local int. So we're going to double. Remember, that's equal to sort of a shorthand there, and then we're going to return that local int back to the main program. The main program will then, so we send in the int to a local int where it's copied to a new variable. We then take that new variable, we double it, we then return that local variable. That then sets the variable which was used to call the function. Now I know this is only an int, but if this was a huge array, that would be a very slow and cumbersome process passing by value. This will work. We need to check how this is all working, so let's put all our bits and pieces in. So I'm going to change the number directly. Let's just check what we've got before we do anything. So la la la. Okay, and then let's see what the number, actually we could do a before and an after, couldn't we? Before, and then after. And we should see a doubling of the number from 10 to 20. So again, call the function with this integer, copy that into a local integer inside the function, double that local variable, return that local variable, saying that we're returning an int, and then change the original int. So 2 ints being passed around, all sorts of copies of information being made. Slow, especially with something huge like a big array. So let's give that a whiz and see what happens if I've compiled everything right. Good. There we are, a nice doubling of the direct int, passing by value change. Okay, we want to speed things up, and we want to make use of C++'s features. So what we're going to do is, from the last lesson, we could change that by reference. So let's just see how we do that. I'm just going to copy this code to speed things up a bit. Okay, so this isn't going to be dir int, this is going to be ref int. So we're going to send off a reference. We'll make it a different number this time. 33, there we are. Now before we call our new function, I'm about to write. What does it look like? And then what does it look like afterwards? Now in this case, I'm not going to return anything and I'm going to save myself the bother of doing that operation. I'm just going to, obviously I'll need to come up with a new function name, so what can I call this one? This isn't a direct number by value change, this is a reference change, so we'll set that up in a second. So we are going to send off the int, and remember this could be big. If it was a big array, a big double array with 1,000 elements, this could be a big piece of data to have to send. Fortunately, because it's only an int, it's quite a small piece of data, but that's a coincidence more than anything else. Okay, let's write this function then. There we are. Now this function is going to be a void function because it's not returning anything, this one. Because when it receives this variable from the main program, it's not going to turn it into an int. It's going to say, oh, I don't care about the int, I want the address of that int. And I've changed the name to a local scope variable. So don't give me the full piece of data, just tell me the address. Just tell me the first point. So don't give me a whole street of houses, just give me the address of number 1. So number 1 Acacia Avenue, rather than give me all the buildings on Acacia Avenue. That should save, later on with a huge array, that would save a bit of time. We would be sending the array, so it's not perfect, but we're just going for the address, the first address on the street, not sending the whole street into the function. Now, because I've just got the address, I'm going to say, well, I'm going to go to that address, and I'm going to, remember, this is another name for the same thing. This is another name for refint. I'm going to double that. So that is going to take this address, it's going to take that as a kind of second name, an alias, and it's going to double that. Now what it's doing is it's overwriting the same memory as is referred to by refint. So from our last lesson that we need to kind of understand, it's overwriting this thing. It's not sending another number back, it's overwriting wherever that is. So that's a bit of fun, isn't it? Okay, so let's see if I've compiled that right. Okay, again, there's a void, but you can put return if you want, but most people don't bother. Okay, let's give that a run. Now you can see 33 has gone to 66. Let's just look at that again. In this case, I create an integer. I send that integer off to the function, but I'm not returning anything. what this function is going to do is it's going to say, I don't want the int itself, actually, thank you very much. I'm just going to take the address off it. And in changing that address, we get, and then doubling what's at that address, we get ref int is changed. Let's just do something a bit funky here. Let's just print out the address of ref int not inline s, and then let's print out inside the subroutine the address of input int, and we should see something quite interesting. Let's give that a run. Notice exactly the same address. It's the same house on the same street. The house has got two different names. It's called Smoky Hollows. There's one name for the house. The next owner comes to the house and says, no, I don't like Smoky Hollows, I'm going to call it Golden Glory. But it's the same int. If we just go back to the previous one and do a similar line there, there's my address line. Oh, there we are. So there only one int was created. See, we're not actually creating an int, so it's got to be something, hasn't it? Get the right thing there, didn't I? There we are. Let's copy that. So there's no, you can see there's no int being created there. Oh, sorry, I've gone for the, put it in the wrong place. That's no good, is it? It's no good to anybody. Oh, really making a mess of things now. Right, let's try that again. Now, we are creating an int, aren't we? We are creating an int, we're creating an int there. Let's run this. So it's too early in the morning for me. And what we can see there is there's two different addresses. That's one int at this address, drr int, and the input int in the function is at a different address. It's a different int, so we're creating two ints in that particular case. Okay then, let's move on to pointers themselves then. Now there's a direct way of doing this, and there's an indirect way of doing this. Let's do the kind of direct pointer way. We're going to create a pointer. Let's type out the for save time if we copy the code and change the names to protect the innocent. First thing we're going to do is we're going to create a new integer, but we're also then going to create a pointer. Actually, it's probably best if I just do all this from scratch and then we can see what's going on, because it's slightly more involved. So this is going to be creating a pointer. So first of all, let's create a new integer, and we'll give this a name, point int. Set that to, well, not 10, 10's boring, 42, there we are. Now what we're going to do is we're going to set up a pointer, and we're going to point it at that int. So we're going to point it at that address, as we saw a couple of lessons ago. The address of dir point int will now be inside pdir point int. Now what we're going to do is we're going to call a function. Again, nothing's going to be returned. But we are going to send off the pointer. And this is going to point, this thing here is pointing at this thing here. And we're going to send off the pointer, we're going to send off a key. Notice, nothing is being returned. Now let's create this, this subroutine. Nothing is being returned. Void. So we'll give this a new local name. So we'll create a local pointer. What we'll do is we'll say, well, we've got this key to this safety deposit box. We'll take this key and go to the safety deposit box it's pointing at, and then open up that safety deposit box, and then whatever you find in there, multiply it by 2. And then, you know, this is a copy of the key, remember? Forget about it. Just go into the safety deposit box, find $1 million, double it to $2 million, and then throw away the key. And then what should happen is that this thing here, we took a copy of a key to that thing, we sent the key off, the subroutine went to the safety deposit box, opened up the safety deposit box and doubled whatever was in there, and then threw away the key. Now later on it's going to be much simpler to send off an 8-byte pointer than it will be to send off a 10,000 byte array. So we'll just send a pointer to an array rather than a huge array. Let's see if this has all worked then. So I think I will just copy these lines now, save a bit of time. So before anything happens, what's that equal to? What's dir pointInt equal to? And then afterwards, after we've sent off this key and someone's gone into the safety deposit box, what does it look like at the end? Okay, let's get, hopefully I've run and written all of this correctly. Here we go, look. Start at 42, there. The thing that contains 42, we take its address, we cut a copy, we cut a key copy, we send a copy of that key off to this subroutine. In this subroutine, we take that copy of that key, actually create another copy of the key, so we've now got 2 copies of the key. We go to the safety deposit, this is the second copy, we go to the safety deposit box and we look inside there, and whatever's inside there we double. And then we just throw the key away. Come back here and we find that this has doubled. So hopefully you're all with me so far. Now you might have noticed there that I actually said we've created 2 keys. Even that is a bit too slow. Let me just copy this. Didn't do enough of these at the start. Even that's a bit too slow. How about we cut out the middleman? How about we don't create a first key and then copy that key so we've got 2 key copies? How about we only do 1 key copy? Can we do that? Yes, we can. This time, again, I'll type it all out in full just so we can all see what's going on. I'm going to use an indirect pointer. So set up indirect pointer int, set that equal to, I don't know, what can we, there we go, it's always a nice number. Okay, now we're going to call a new function, again another void. Actually, no, actually we don't. We can reuse this function here. We're going to do a bit of magic. We're not going to bother with this middleman line of taking the address of the integer, creating an integer pointer to that thing, and then sending off the pointer. So we're not going to copy a key and send the key. We're just going to send off an X-ray of the original location. So we're just going to send off the address directly. We're not bothering with this middle line here of creating a pointer and then sending off the pointer. We're just going to do all that in one hit. Now this should be even quicker because we're doing one less operation. Now we're using exactly the same function as we used here. So let's have a look at it again. This address to this int is sent directly off to this function. It takes that address and says, aha, I shall create a local pointer, a local key, one key this time. With that one key, I shall go off to the safety deposit box, I shall look inside it, I shall double whatever's inside there, and then I'll throw away the key. And then this should get doubled directly. And this will be really, really quick once we start talking about huge values being sent off to subroutines. So again, we need the we need some proof for this. So let's just get the proof. India point int, and then we'll do the after version where it should go to what, 138. I've got my maths right. Okay, let's. I'm just crossing my fingers. Let's give it a type, give it a run. There we are. So now we have reused the same pointer function, void pointer function, but without having to create a middleman. We've just gone direct for the address. We're putting the address directly into the subroutine. Subroutine picks it up, says, ah, here's an X-ray of a house. I'll just copy that key to that house, find what's in there, double everything, and then throw away the key. So find it, double it. Okay, that's the 4 different ways of changing an integer. So just to recap, we can do it directly by passing by value. We send off the whole value. Subroutine creates a copy of the whole value, sends back a copy of the value which has been changed. We then copy that changed value into the old value. Very slow, especially when we start talking about large bits of data. The reference is a neater way of doing it. We send off the integer, but the function says, oh, I don't care about the integer, just give me the address. Just give me the address, that's all I'm bothered about. I'll go to the address and I'll change whatever is at the address. The direct pointer, we create the integer, we then create a key, a pointer key to that address. We then send off the key. Inside the subroutine, we take a key, we copy it again, go to the safety deposit box of the house, double everything, and in the final one, we don't even bother with the pointer in the main program. We just send off the X-ray, the pointer X-ray, to the function, which takes the X-ray, creates one copy of the key, changes the value inside the safety deposit box, and then throws away the key. I think that's probably enough for the moment. I think we now need to get on to pointers and arrays and pointers and strings. I'll have a think about what's the best way to go next, but it'll be something to do with pointers and arrays or pointers and strings. See you next time.